Come so we'll quote from the basic, okay?
Yes, sir.
How your face recognition works. So say for instance I have a database, okay? This is a standard face database, okay? These are called classes. So this 4 face belongs to only one person.
Yes, sir.
Their pose their pose varies, okay? So we call all of them together as class 1, whereas this 4 faces matches, we call them as class 2, similarly class 3, class 4, okay? Now each independent photo of a class is known as an instance. So there are 4 instances of class 1, there are 4 instances of class 2, there are 4 instances of class 3, there are 4 instances of class 4, and out of them you can see that 2 are with specs and 2 are without specs, okay? So basically when you talk about a classification problem, okay, face recognition, what's a face recognition system? A face recognition system is basically a classification system. What is a classifier? What you do is, first you take some training classes. A training class is nothing but the category of the data that you are going to train. That means category or label of data. As I have said that here, as this 4 belongs to only one person, we'll say that this is class 1. As this 4 belongs to second person, we say class 2. So whenever we are implementing a real-time face recognition system, you need user to register his face, okay? So when the first user is registering, he is first person. When the second user is registering, he is second person. That means registration process is nothing but including a new class. Understood? Okay. So you see, when you start teaching a child, okay, if you show that this is ball, when you show him different types of ball, he can make a logistic analysis. Okay, anything round is like a ball. So classifier is also like that. You need to train it with enough data so that classifier understands what exactly is the model. So basically you cannot compare photo to photo, because if I compare this to photo, there is no similarity, right? He is looking at different direction, he is looking at different direction. So the role of the classifier is to extract some features by means of which it can identify that which class it belongs to. And because from image to image such features would vary, it essentially requires more than one instance per class to remember. So our training classes, category or labels, these are nothing but instances of a person. Instances of a person, okay? Now this is photo 1 of say person 1. This is photo 2 of person 1, photo 2 of person 1. Similarly, you can have photo 1 of person 2, of person 2, and so on. Now, as we understood that we cannot directly compare the images, because if I subtract this image from this image, there will be a lot of difference. If I subtract this image from this image, there will be a lot of difference, okay? So we cannot directly compare the images. So for that, we require to extract the features. Okay? There could be several types of features. What are these features? The features could be color features, texture features, shape features like age, contour, etc. Then it could be descriptors or models like local binary pattern. It could be descriptors like some kernel descriptors like your eigen, and so on. Okay, so you can give the features. So these photos, I mean, from all these photos we extract the features. Okay, and these features are then stored into a database, because you need to have comparison, right? For comparison you need to store them somewhere. Okay, so all these features are going to be stored in a database. Okay, so what we are storing in the database? We are storing a set of features, comma, label. This process is known as the training process. So we'll call this process of giving input as, so this entire process of giving input, images, then feature extraction and storing the feature together. This process is commonly known as a training process. Okay, once training process creates this image, your main face recognition system has access to this database. So whatever database the training process creates would be available to face recognition. Now, what is the task of face recognition? You will give one face as input. It should be able to tell whether it belongs to person 1, person 2, person 3. Okay. So what is your input to the system? The input to the system is an, say, unknown face. Okay, we are talking about classification problem. There are several other variations. In a face authentication system, you also provide the label, that is person 1. This face belongs to person 1. Its role is to check whether this face is a person 1 or not. But here we are right now talking about the classification problem. So we will not be providing the label, we will just provide a photo. So what will happen is, because I cannot compare a photo with the photo, because in the database I have not stored the photo, rather I have stored the features. Okay, so what I am going to do is, I am going to again take the help of this feature extraction method, and I am going to extract the features, okay, of this photo, which I will be calling as test features. Okay, so this is a set of this is a set of F. Now if you see the difference, I have all the features as well as their labels in the training process, and I have only the features for the test. Now the role of the face recognition system is to take this and take this database features and then compare. Okay, so whichever it is close to, so there are suppose 10 faces which have been trained, this feature is close to whichever face, based on the closeness measure obtain the label. So obtain label as output based on closeness. Okay, how do you define the closeness? Suppose I had only one feature, some number. Okay, suppose my table was like this, that feature was 1.0, class was 1. Okay, next feature was 1.5, this was belonging to class 1, because I am giving multiple instances. Suppose my feature was 3.6, class was 2. Suppose my feature was 3.9, class was 2, and suppose my test feature is something like 1.8. okay, now comparison in this sense basically distance measure. So when you subtract this from this 0.8, when you subtract this from this 0.3, so what are the distances? First is 0.8, then 0.3, then around 1.8, then around 1.1.8. 2.1. Okay, these are the distances. We call them as distances from training data. Out of them, which is smaller? Obviously, this is smaller. Okay, this belongs to which class?
Class
1. So it should say that this photo belongs to
Class 1. Person 1.
person 1. All right. Now we'll see how do we code this in Matlab. When we go for the Matlab coding, first when you open the Matlab, we have a folder over here, okay, called Abhilasha face. I'll select this path and I'll put this over here. Okay. I'll take a new file because I'm writing the code right now. When you open, you have to just open the file. You do not have to write this file. Okay. I'll save it as a name as a module 1. Okay. Now the first thing, I have two process. Say module 1 underscore training. Okay. So suppose I'll want the user to browse one file. Okay. So fname path equal to UI get file. Open a face as input for training. Okay. So whatever face, the faces are all BMP face or PNG. They are JPG faces. Okay. So I'll keep start.jpg, so only JPG images will be opened. Okay. And because it will return path and fname both, file name equal to path comma fname. Okay. IM equal to IM read fname. Okay. IM show, IM title, input face. Okay. Now it should ask the user to enter its class. Okay. So I'll be asking the user to give a class. Say for instance C equal to input. Enter the class. Okay. So whatever class he does, along with this he cannot store the face. Rather he has to extract the feature. Okay. So this is taking an image. The next module will say feature extraction. When you look at this image, you can easily see that this feature extraction is utilized by training part also, testing part also.
Yes,
okay. So rather than making it independently to training and testing, we'll write a common feature extraction program which should be used by both training and testing. So we'll write feature extraction as a separate file. Okay. So function, the feature extraction function should return a value called f. Okay. You can give any name equal to, so let us say feature. let me take statistical features, simple, okay, and it should take an image as input, okay. Let us save this. So whenever you write the function statement, the file will be saved with the same name as the function.
Yes.
Okay. Now I'll take the mean and standard deviation from the image. So mean of IM. Okay. So standard deviation is, now you see there is a problem. Image is two-dimensional. So if you take mean, you will be getting 256 means.
Yes.
If the image size is 256. So in order to get a single mean, what I'll do, I'll take mean of mean. Okay. Similarly, standard deviation of, as you can know that mean and standard deviations are most prolific statistical feature of any object. Okay. And then I'll say f equal to combination of mean and standard deviation. Okay. So I can extract the feature simply by calling f equal to so it will return the features. Okay. Now what I am going to do is I have to store this feature into a database. As you can see that I have a database, I have to
Yes, sir.
store this feature into database. So I'll be first trying to load the database. Load say database. Now at the beginning I have not created the database,
Yes, sir.
so it will not be able to load the database, right? Because of this I'll be creating this database. Okay. So say for instance db equal to a space f comma c. So what is my structure? Suppose mean and standard deviation is 10, 12 of first person, it will be stored in this fashion. Second person, and I'll be storing it. So save db db.mat is the file name on which I want to store. So if it was able to load, it is fine. So suppose I already have features. Okay, in Matlab how do we save the data is, suppose db equal to 581, 1 stands for first person. Okay, I want to save one more data, so it's a matrix. Okay, it has got one row. So what I am going to say is db equal to db semicolon. So I'm going to write db is equal to db semicolon, say f. It is in this way. So if I give semicolon, next data will come into next row. Okay. So in that way I am going to save it. Load db. If it was not there, it will create a new db. If it is able to create f equal to, you have already calculated the f. Along with this you have to mix c. Okay.
Yes.
So in the third column the class name will appear. Then db equal to db semicolon f. So it will come into next this thing and save db as db dot mat. Fine. Let us check. When I run, it is going to ask me for a first. Okay. So I'm going to take first phase as input. Okay. It is asking me which class. This is person 1. Okay. There is one problem. Standard deviation is a function which will return numeric values like 1.2, 2.3. The database of image in Matlab is uint8, as you can see, unsigned integer 8-bit. On integer we cannot apply standard deviation. So what we need to do is we need to convert the image into double data type. So im equal to double of im. Okay. Here I want to clear off all the existing results. So clc will clear the command prompt, clear all the images will be closed, and here I want to just take it in front of this. Okay. So I'll give first person. It is asking me class number. I'll give 1. First should be file name, then the variable name. Now you'll see that one database gets created over here. Okay. When you open the database, you can directly open the database in this fashion. As you can see that it has got 3 columns. First two are the features, second one is the class name. Alright. I want to give one more image of first class. Okay. Enter the class. This is also first person image. So I'll give 1. Okay. Now I'm going to at least give one more class as input. I'm going to run. Take second person. Okay. Set this person. Give the class name as 2. So half of the images you can use for training, half of the images you can use for testing. Now I'm going to run it once more. I'm going to give any image of the second person. Say class 2. Now I can see a clear distinction. The first person's mean was in this range. Second person mean was in this range. First person standard deviation was in this range. Standard deviation is in this range. Now I actually want to write the classifier, so I'll write one new module. Okay. Here we'll give provide a phase for testing. Okay. But you are not supposed to give its class. Find out which class it belongs. Okay. Find out which class it belongs. So how do you find out? If you look at this diagram, the process compares the test features with the training features. So for the test image also you have to first extract the features. Okay. So that's what I'm going to do. First f equal to extract the features. Okay. I have extracted the features. Once I extract the feature, I have to compare with the database. So okay, but in the database what we have is 3 columns we have, but here I have only 2 columns. So if train equal to the database variable name is db. Okay. So ftrain equal to db of, I want to know all the rows but only first and second column. Third column I do not want to know. Okay, and training classes equal to db all the rows and the third column, because the third column has face labels, first and two columns has the data. Okay, now it's a distance based classifier, so I should be able to calculate the distance. Now distance equal to absolute of ftrain minus f is my test feature, more prominently let me call it ftest. So if I subtract both, I'll get this matrix, that is distance from all the features. I have to find out the minimum of it, right? So m equal to find dist equal to minimum of dist. If it has got more than one matching, just one instance I wanted to return. So it will return either 1, 2, 3, 4 based on whichever is matching. Okay. So detected class equal to whatever your training data was. As you can see from this, if this is this index, I want to find out the label associated with this index. Okay. So whatever training class is C train of n. Okay. Perfect. Now, first two phases I had already given for training. Now let me give this phase. This was not trained, right?
Yes.
What's the problem? Okay, because this has got several values, I need to take a loop. For I equal to 1 to size of ftrain comma 1. 1 stands for rows. Okay, so as many number of rows are there, those many number of times I want to calculate this train of particular row, all the columns. With this I want to subtract this. I will again give this as input. Say this phase I'll give as input. Okay. Okay. I have to actually add the distance, because there are two columns, so it is written in two distance. I'll club them into a single distance. So here it is an underscore. So this is person 1. Okay. Now, let us give person 2. Say this face. Okay. Says person 2. Now there is a problem with this technique. What I run, I give some other face, but it is going to show either 1 or 2, because my code is written in such a way that it always detect one person. Okay, because see, there is no rejection rule. So one part of your classifier should also be to reject. So how I can reject? What I can do is, first I'll test what is my range of distance. I'll keep this as input. It is showing test 1. Let me see the distance matrix here. See, the distance is very small, 2.4, like that. I'll give second person as input. Okay, so see, I'll give this phase as input. I'll again see the distance. What is the distance range? It is less than 2. Okay, what I'm going to do is, first I'm going to find out the minimum distance. Okay, and then I'll threshold. If minimum is less than, say, 3. Okay, else if minimum is not less than 3, then it is not trained phase. Okay, right? So now let me give this phase. Okay, now let me again run this training program, include the third phase, that is this person's phase. Let me call this class 3. Okay, again let me run this. Let me call this class 3. Now let me give third person as input. It detects it as class 3. When I give second person as input, the distance is moved. This case is called false rejection. Okay. Detected class 1. So in this way your classifier will be able to detect few correctly, will be able to detect few wrongly. Wrong detection will be again divided into false acceptance, false rejection. Okay, it might happen that if you give some cases where the user is not at all registered, still because of the smaller distance it may detect it as person. This is the correctness. So this is the overview of how your phase